Today we are starting Chapter 3 and we're looking specifically at quadratic functions. We're going to analyze their graphs and find x-intercepts, y-intercepts, the vertex, and the axis of symmetry. We're also going to decide if the parabola opens up or down and whether it has a maximum or minimum. Finally, we'll take the graph of a parabola and go backwards and write the equation of it from the graph. These are all the steps that you'll need to follow in order to find the intercepts and the vertex, the axis of symmetry, and the maximum or minimum. Example 1, f of x equals x squared plus 5. Let's start by finding the x-intercepts. This is just like finding zeros. We're going to let y equal 0 and solve it for x. So add 5 to both sides, and then take the square root of both sides. So the intercepts are plus or minus radical 5. You need to write these as coordinates. And then graph them. Radical 5 is going to be a little bit bigger than radical 4. So it's just a little bit more than 2 and a little bit less than negative 2. So those are the x-intercepts, or the zeros. Next, we're going to find the y-intercepts. In order to find the y-intercept, you're going to let x equal 0. So the y-intercept is negative 5, and again you write it as an ordered pair and graph it. So there's your y-intercept. Next, we're going to find the vertex of the parabola. In this case, the equation is already written in vertex form. Vertex form is y equals a parenthesis x minus h close parenthesis squared plus k. The h is the x-coordinate of the vertex, and the k is the y-coordinate of the vertex. So in this problem, the h is 0 because the x squared doesn't have a minus in the parentheses, and the k is the negative 5. So the vertex happens to also be the y-intercept for this problem. Next, we're going to find the axis of symmetry. The axis of symmetry is the line of symmetry that goes through the middle of the parabola. It's always going to be the x-coordinate of your vertex. So the axis of symmetry in this case is x equals 0. And again, the 0 is the x-coordinate of the vertex. So I'm going to go ahead and try to draw this axis of symmetry. Going to go right through the middle of the parabola. So now we can sketch this parabola, and the parabola, you can see, has the vertex at 0, negative 5, and it goes through our two intercepts. Now the other question that we were asked was whether or not this thing had a maximum or a minimum. Since the parabola opens up, it's going to have a minimum and the minimum value is the y-coordinate of the vertex. Now the other place you can look to determine whether or not the parabola opens up or down is at the value of a. So up here, since the coefficient of the x squared is a 1, Since that's positive, it tells you that it opens up. Example 2. The x-intercept, we're going to find it just the same way we did last time. Set the function equal to 0. Add the 6 to both sides. Take the square root of both sides. And subtract 5. So the the x-intercepts are negative 5 plus radical 6, 0, and negative 5 minus radical 6, 0. Those are going to be approximately negative 2.550 and approximately negative 7.450. Now my graph is going, my intervals are labeled by units of 2. So negative 2.5 is going to be about right there. And negative 7.5 is going to be about right there. Now let's find the y-intercept. Substitute 0 for x. And the y-intercept is 0, 19. The vertex of this graph will be negative 5, negative 6. And I know that because the h is 5, so you have to use a negative 5, and the k is negative 6. The axis will be x equals negative 5. That's your line of symmetry. The coefficient in front of the x squared, that 1 is positive, so the parabola will open up. And it will have a minimum value of negative 6, the y-coordinate of the vertex. Next we will draw this. You'll have to forgive me. Drawing parabolas with this airliner is very challenging. This is supposed to be a parabola with a vertex down here at negative 5, negative 6, and it goes through your intercepts, all 3 of your intercepts. Just make sure you have your points labeled appropriately. All right, next, this time the parabola is in standard form, but we're still going to follow all the same steps that we did before. So to find the x-intercept, we're going to let y equal 0. And to solve this, you can complete the square, factor, quadratic formula, whatever you'd like to do. I'm going to choose to use quadratic formula. So x equals the opposite of b plus or minus square root of b squared minus 4 times a times c, whole thing over 2 times a. So we end up with 4 plus or minus the square root of 16 minus 4 times 4 times 21, and that's going to be negative 320 over 8. Now we have to stop here because we have a negative under the radical. When that happens, that tells you that there are no x-intercepts because we're not going to deal with imaginary x-intercepts. Now we're going to find the y-intercept. Let x equal 0. So y is 21. So our y-intercept is going to be about right there. Next, the vertex. Since the formula is in standard form instead of vertex form, we're going to use the little formula that was on the front page of your notes that says that the x-coordinate of the vertex is negative b over 2a. That means the x-coordinate of the vertex for this problem is going to be a positive 4 over 2 times 4, which is 1/2. Now to find the y-coordinate, we're going to substitute. The y-coordinate is going to be 4 times 1/2 squared minus 4 times 1/2 plus 21. 4 times 1/4 minus 2. So 1 minus 2 plus 21. Negative 1 plus 21 is 20. So the vertex is now 1/2 20. And we're going to graph that. One half 20 would be about right there. Next, we know that the graph has a minimum because the leading coefficient is a 4 and it's positive. So the minimum is going to be 20, which is the y-coordinate, and the graph is going to open up. The axis of symmetry will be x equals 1/2. So we can draw that axis of symmetry, and that will help us to graph the parabola. We have the y-intercept at 0, 21, and so we'll have a corresponding point on the other side of that line of symmetry, and then you can draw that parabola. That concludes part 1 of the video notes for section 3.1. Part 2, we're going to do the very same things except with the calculator. So please get your calculator ready and then start part 2 of today's notes.